So, hi everyone. Let's start today's session in the course Joy of Programming with Python using Python. I believe there are very less number of students. So let's wait for a few more minutes and then we'll start the session. So, hi everyone. Welcome to today's session, tutorial session on Joy of Programming using Python. I'm Rupesh Kumar, and today is 23rd August. This is our fifth session. Joy of Programming using Python, and I am Rupesh Kumar. Today is 23rd August 2024. The session goes from 6 to 8 p.m. Fine. So, just for a confirmation, am I audible? And is the screen visible? Can anyone just confirm? Just type in the chat box. Great, I hope. Great. So the meeting is being recorded, okay? And it will be shared with you guys after the session. So in this week, you saw what are dictionaries in Python and how to use dictionaries to solve simple problems. So let's get you started with the dictionary. So we'll be using the Spider console that we have been using since the beginning of this semester. So let's see what are dictionaries in Python. So is the text visible? Anything I'm writing here is visible to you guys? Is the font size fine? Great. So what are dictionaries? So dictionaries are data structures that's used to store data in pairs. The pairs comprise of key and value. So let's say you want to store a student information. Let's say student information of a student. Let's say the details of the students are his or her name is Ram. They belongs to class 10th, and let's say their address is New Delhi. So how to store this information in a single data structure in Python? So we can use dictionaries. As I already stated, dictionaries are used to store data in pairs. So and these pairs are represented by key and value. So for each key, there has to be a value. So for defining a dictionary, let's say dict, let's say student details. I want to create a dictionary, student details. So you have to use this curly braces. Fine. Can you see this curly braces? So it's a curly open and curly close. And within this, you can create a dictionary. So let's say if I uh, create this dictionary, you can see this is a blank dictionary right now. So I already told you guys that it contains a key and value pair. So how to write those key and value pair within this curly braces? So you have to write in key here. Let's say I have a key, and then I have value. Note that this key value pair can be anything. It can be a string like this. It can be the value can be number and the key can be string like this. Even the key also can be a list, can also be an integer. Then if you want the key to be an integer and the value to be string, you can use this and so on. Fine. So the key can be of any data type and the value can also be of any data type. Fine. Okay. Hmm. So yeah, let's get to dictionaries. Now let's say if I want to create multiple keys, uh, let's say I call it dictionary D, and I want to create multiple keys. I want to create a dictionary that contains numbers and the numbers in like in numbers, normal decimal numbers, and then their word representation. So let's say I call it a dictionary numbers. Okay. So now let's say I want to store the digits. So what is zero called in English? It's zero. So again, I can now let's say if I want to enter multiple key value pairs, we can enter a key value pair. So it's a key followed by a colon, then its value. Then I can use a comma to enter next key value pair. So comma acts as a separator. Similarly, so comma is very same as we have seen in the list. So now one is the second digit and it's called one. Then again two and it's called two and so on. Oh yeah. Fine. So now when let's say you want to see how to access a value from a dictionary, you can use key for accessing values from the dictionary. Now let's say I want to get the value stored for the key zero in the dictionary numbers. I can use these square brackets to access the value. So numbers at zero, it will say zero. Similarly, numbers at one is one and numbers at two is two. So this is how you can define different a dictionary having multiple key value pairs and how to access those values. Now, let's say you are given a dictionary numbers and you don't know the keys of this dictionary and you want to get the keys of this dictionary. So you can use simple function numbers dictionary dot keys. It will return the keys present in the dictionary. So here you can see it says dict dot keys 012. It returns a list that contains the keys present in that dictionary. Fine. Anyone? Do you have any doubts till now? Great. This means I can assume that now every one of you is familiar with dictionaries in Python. Fine. Now let's go back to our original problem. We wanted to create a dictionary containing the following information of a student. Fine. So let's call the dictionary student details. And what are the keys? The keys are name, and the name of the student is Ram. Then the next key is class, and the student belongs to class 10, so class can be 10. And then the key is address, and the student lives in New Delhi. Fine. So in this example, you can see we have stored the details of a student in a single dictionary. Fine. And most importantly, you can see the dictionary contains multiple key value pairs. Also, the data type of one of the key value pair is different from the other. So here you can see for the class key, we have a 10 stored for the as a value, which is an integer. So this is also possible in Python dictionaries. Now let's say if I want to print the student details. So what is the student's name? I can simply pass in string. So whatever the data type of the keys present in the dictionary, that same has to be used for accessing the value from the dictionary. So what is the student name? Student name is Ram. So what is this? In which class does the student study? It's class 10. And where does the student live? He or she lives in New Delhi. So this is how you define dictionaries in Python. Right? So let's start with our first question. What happens if you try to add a new key value pair to a dictionary using key that already exists in a dictionary? So currently our student details had the following keys. Student details, it had the keys names, class, and address. And currently, the name key has the values RAM. What happens if I try to update the value, update the value for the key name as, let's say, Sham? Then what happens? So let's see what is the behavior. Here you can see the student name gets updated as Sham. So what is the behavior? What happens if you try a new key value pair to a dictionary using a key that already exists in the dictionary? Then what happens? Now you already have seen the behavior. Can anyone answer? The new value overrides the existing value, and error is raised, the dictionary becomes immutable, or the new value is appended to the existing value. Anyone? Option A. Correct. Correct answer. Option A. The new value, the existing value. Fine. So this is the correct answer. Let's go to the next question. So does anyone have any doubts regarding dictionaries, basics of dictionaries, how to use them, how to declare dictionaries in Python, and so on? Fine, I believe no one. So let's go to the next question. Uh, So I hope you all have went through the lectures videos where there was a lecture on rock paper and scissors game without cheating. So there was some methods were used to allow the players to play rock papers and scissors, and moreover it allows them to play in front of each other, so the player can see the move of the next of the next opposite player, but still they cannot figure out what is the move that the opposite player has taken. So for that, some manipulations were done in the algorithm. So I hope every one of you are familiar with this. So now this problem talks about an extended version of the rock, paper, scissors problem. So it says in the popular TV show, The Big Bang Theory, the extended version of rock, paper, and scissors game was introduced. That contains rock, paper, scissors, lizard, and Spock. Fine. So, and here are the rules for this game: rock, paper, scissors, lizard, and Spock. Rock wins against scissors. Fine. Scissors win against paper. Fine. Paper wins against rock. Rock wins against lizard. Then lizard wins against Spock, and Spock wins against scissors. Scissors wins against lizard. Lizard wins against paper. Paper wins against Spock, and Spock wins against rock. So total we have total five of five tools that can be chosen in the game. Fine. And uh, the and the strength of the and the strength the strength of these tools, whether which tools wins against which tool, is provided by these rules that you can see. So now each option can defeat two other options, lose to two other options, and draw with one other option. So that makes sense. So it can draw with itself only. Each option can defeat, like rock can draw with rock only. Paper can draw with paper, and scissor with scissor, Spock with Spock, and lizard with lizard. So each option can defeat two other options. So and lose to two other and draw with one other option. So for each, let's say if I choose rock, then how many options we have? We have four remaining options. Then if among the four, if then among the five even, if you choose rock, then there is a draw. So this is the first option. The second option is we can use scissor, then rock wins. We can use paper, then rock loses. So let's see where rock wins. So rock wins against scissors and lizard. So there are two options. So total three. One draw and two win. Then it loses against paper and Spock. Paper and Spock. So total five options. So yeah, this makes sense. So now major steps involved in the algorithm for coding a rock, paper, scissors game were discussed as follows. Discussed in lectures were as follows. So first thing that they did is assign values to the choices. The first thing is you have to assign values. Each player have to assign certain numerical value for these options. So mm, let's say one for rock, two for paper, three for scissors, zero for lizard, five for Spock. Fine. Now what they had to do? We had to input user choices. The algorithm asks the user to input their choices for the game, such as rock, paper, or scissor. So the simplistic way is simply pass in the number corresponding to rock, paper, and scissor. In this way, it is very easy for the opponent to guess what option you are choosing. So to prevent this, a secret bit coding method was used, where the user was free to choose any of the numbers for any of these options, as well as the user was allowed to define the secret bit position. So user was asked to enter a 10 digit number. Then the user was asked to first the user was asked to enter the secret bit that will give the actual option to us. Let's say the user says the secret bit is 4. So let me type it here. So how did we solve that problem? So let's say we have a user 1, then their option mapping was like this. So let's say they call 1 for rock, 3 for paper, 4 for Spock, 2 for scissor. I don't remember this spelling. Huh. 2 for scissors and 0 for rock, paper, lizard. Fine. So let's say user 1 uses this option. Then the program asked the at that point we did not have Spock and scissors. So let's remove these. At that time, the user was now the user was asked to input a secret bit location. So basically, what is the secret bit location? So let's say the user says the bit number 3. Now, what the user was asked? User was asked for the option in option string. So it contains 10 bits, and the third bit represents our option. So let's say user option enters 0, 7, 6, 8, 9, fine, and the 1, 2, third. Third is 3, 10. Okay. Now let's say user enters this option string, which is a 10 digit number. Then what is the secret bit location? The secret bit location is 3. Now what is 3 here? What is placed at the location 3? Location 1 contains 0, location 2 contains 1, and location 3 contains 3. So the secret bit is 3. Now what the program does, it gets the chosen option is the value at secret bit modulo 3. Fine. So what is the chosen option? 3 modulo 3, which is so basically they were 0, 2, 1. Now it makes sense. The value at the secret bit modulo 3. So what is the value at secret bit 3 modulo 3? That is 0. So what is 0? 0, rock. So user 1 is saying I choose rock. The same goes for user 2, and the game proceeds. Now what happens? Let's say instead of these 3 options, we have this doc will be shared with you guys. Let's say we have instead of 3 options, we have 5 options. Then what happens? Let's say 4 is lizard, and then 3 is Spock. Then what are the changes that need to be made in order to use or reuse our algorithm? So let's see. So the first option is assigning values to the choices. So yeah, this is correct. This does not need to be changed. Then inputting user choices. The algorithm prompts the user to input their choices in the game, such as rock, paper, or scissors. Fine. Huh. So it says assigning values to the choices. The algorithm involves assigning numerical values to the rock, paper, and scissor choices. So instead of 3 now, we have to give 5 choices. Now we have to give 5 choices. Not we, now the user. Now the program to assign 5 numerical values to the choices. Fine. Instead of 5, because we have 5 options. Fine. The second step in the algorithm says inputting user choices. The algorithm prompts the user to input their choices for the game, such as rock, paper, or scissor. More or less, we don't need to change anything. That's fine. Then secret bit positions. So the algorithm uses secret bit position to determine the winner of the game, which involves bitwise operation to compare the choices and determine the outcome. So just remember, in the code we were using for 3 bits. Now we are comparing for 5 bits because there are total 5 options. Then coding rules. The algorithm includes coding rules for determining a winner based on the choices made by the players, such as if-else condition to compare. So we don't need to change this because the if-else conditions are same for who wins or not. Then finally we run the program. Fine. So let's see which options are correct. What are the possible changes in the games? So step one would involve assigning 5 values to choose instead of 3. So correct. And then, so option A is correct. Then option B says the bitwise operation involved in step 3 would involve modulo operation with 5 instead of 3. So that's true. We have to do modulo operation with 5. None of the above is false. So none of the above, all of the above is correct. So option D. Fine. Anyone, do you have any doubt with this problem? So just type in the chat box. Oh, oh yeah. So there's been mistake. Yeah, you are pointing out correctly. Option D is incorrect because it says all of the above, which includes the option C, which is not correct. So only options A and B are correct. Everyone, please pay attention. I told that all of the above is correct. It means that options A and B are correct, not option C. So the correct answer would be options A and B. So I believe no one has any more doubts. So let's proceed further. How does bubble sort compare elements in an array? So everyone, do you remember the bubble sort algorithm? I guess someone is typing something. So do you have any doubt? So you're not familiar with the modulo operator? So basically, modulo operator returns the result of remainder. Returns the remainder of division. So let's say odd 8 modulo 3 is 2. Fine. So you are saying how it will choose. So let's say it's 3 modulo 3, it says 0. What is 0? 0 goes for rock. Fine. Also, if you have confusion with the algorithm, then you can go back to the lectures and you can see there. If you are not familiar with the modulo operation, then I can help you out. Fine. So please go back and look at the algorithm. So everyone, let's move to the next question. So are you familiar with bubble sort? So what is bubble sort algorithm? Let's say I have a random. So let's say we have this. So yeah, someone is typing some queries. So yeah. So let's start with bubble sort. So what does bubble sort do? Mm, So yeah, you can go back to the lecture slides and see how that algorithm worked. Fine. So let's see how bubble sort works. Fine. So let's see we have a list like this. So we have list containing some numbers like this. So what does bubble sort do? It starts from the first index, the the value at the first index in the list, compares this value with the value stored in the adjacent entry. So there is a comparison. Let's say we are sorting in ascending order. If this value is greater than this value, then we have to swap. Fine. Now what it does, it checks this value with the next value. And this goes on until the largest number comes at the last position. Then this part of the list is sorted and this part is unsorted. Then again, the process repeats and one by one, we get the sorted list. So let's see how it works for this example. So first it compares 1 with 4 and we can see we don't need to swap 1 with 4 because 1 is less than 4. Now it checks 4 with 2 and it says 2 is less than 4. So it swaps them. So it becomes 2, 4. Hmm, nine. Okay. Now what it does, it checks 4 with 3 and swaps them because 3 is less than 4. Now it checks 4 with 8 and it sees that 4 is less than 8. So no need to swap these values. Now it checks 8 with 7 and it sees 7 is less than 8. So 7 is swapped. Now it compares 8 with 0 and it sees 0 is less than 8. So 8 and 0 are swapped. And finally it checks 8 with 19 and it sees 19 is bigger than 8. So the first iteration is over where throughout the list. So where the largest value is now located at the last location. Similarly, this repeats for the second iteration until the smaller sublist, this sublist. And this goes on until the entire list is sorted. So how does bubble sort compare elements in an array? The correct answer is It compares adjacent elements and swaps if they are in the wrong order. That's true. Compares random elements. No. Compares all elements with the first element. No. Compares elements in the reverse order. No. So the correct answer is option A. Bubble sort compares adjacent elements and swap them if they are in the wrong order. Fine. Anyone? Do you have any doubts? So there's so you have to define what iteration by what iteration is the meaning of an iteration. What I am talking about is one iteration where all the values have been checked throughout the list. Fine. So there can be multiple swapping in swapping operations in one one iteration. If you talk about just swapping two values, then it is only one swap. But let's say for the first iteration for this went till this went for total 1, 2, 3, 4, 5, 6 steps. So the first iteration for this example ended in 5 steps. So these all 5 steps comprise of one iteration of this bubble sort. And that involved, I guess, 1, 2, 3 and 4. Four swaps. So in each iteration, it does not the number of swapping is not constrained. I mean not fixed for each iteration. Fine. Anyone, do you have any doubts in this algorithm? So finally, you can see we get the sorted list. So in each iteration, there can be multiple swaps depending upon the size of the elements. So the question is how many iterations it will take to sort a level list. It will take at max, it will take n square iterations. So basically an iteration. So you are trying to fill one every. So let me see what we are doing in bubble sort. So let's say we have this list. Fine. It contains few values. For each iteration of bubble sort, what we are doing, we are taking the maximum value and placing it at the last index. So let's say what is the maximum number of times that we have to do this is that will ensure that the list is sorted is total number of elements, because first the largest element will be placed here, then the second largest will be placed here, then the third largest will be placed here. So total n-1 steps are required here. Fine. In the worst case, it is n-1. In the best case, you have zero swaps. Fine. Anyone, do you have any doubts? I mean, yeah, you have to do order of n search for each iteration. So for each entry in the list, you have to do this so that first we get the largest value, place it at the last place, then second largest value, place it at the second last place, and so on. Right. So let's go to the next question. To sort a list in ascending order, when does bubble sort exhibit poor performance? What is the answer, anyone? When does bubble sort require all swapping operations in all the iterations, in all comparisons, when it will require it. So can anyone tell me what is the total number of swapping requires in this example? Anyone? Let's say we have a list like this, sorted list, 1, 2, 3, 4, 5. How many swapping? Zero swapping because the list is sorted. Now let's say we have this list. In this case, how many swapping? Anyone? One swapping. Okay. Now, because the value 3 and 2 are not in correct order, so they will be swapped. Now, what happens if we have this list sorted in descending order? Then how many swaps do we need? So total, now it will require total swaps. In first iteration 4, second iteration it will require 3, third iteration it will require 2, and fourth it will be 1. So let's see how. So it will be 4, 5, 3, 2, 1, then 4, 3, 5, 2, 1, then 4, 3, 2, 5, 1, then 4, 3, 2, 1, 5. So this is iteration 1. So we required 4 swaps. So let's go to iteration 2. So we have this list again, 4 and 3 are swapped. 3, 4, 2, 1, 5, then 3, 2, 4, 1, 5, then 3, 3, 2, 1, 4, 5. So total 1, 2, 3, 3. 1, 2, 3, 4. So total 3 swappings. Fine. In the first step, we saw we had 4 swappings. In the second iteration, we have 3 swappings. Then again, in iteration 3, we have the list 3, 2, 1, 4, 5. 3 and 2 are swapped. Then 1 and 3 are swapped. Total 2 swapping. Now in iteration 4, we have 2, 1, 3, 4, 5. So now 1 and 2 are swapped, and we get the answer total 1 iteration. So total 7 iterations. So as we can see, if the list is sorted, we do not require any swapping. If the list is unsorted randomly, then it requires some number of swappings, but it is guaranteed when the list is in descending order, it requires most number of swapping. That is, it exhibits very poor performance. So the correct answer is option B. Fine. Anyone, do you have any doubts? So no one has any doubts? So yeah. So what is the doubt here? Vijay, can you just type in what is the issue? What you want to understand in this? So where you are stuck? So I explained. Are you able to understand if the list is sorted, then we need only one swap, 0 swaps? So do you understand this? So are you familiar with the bubble sort algorithm? So you haven't seen the lectures. So you have seen the. So what do we mean by swapping? Can you tell me? So why swapping is what is the swapping that we are talking about right now? Huh? Are you familiar with swapping? Why we are when we are swapping values? So in bubble sort, whenever we sort a list containing numbers, what happens? We check for values. So let's say we have a list and it contains the following values: 2, 1, 4, 3. Fine. And we want to sort this list. Okay. So what we do, we start from the first element in the list. We compare its value to its adjacent value. So which is bigger, 2 or 1? Is this correct order? Can you tell me? So is the order correct? 2 followed by 1 if we want to sort ascending? No. So what you do, you swap these values. So by swapping, what I mean? By swapping, I mean you copy this 1 here and 2 here. Now our list becomes 1, 2, 4. Again, now you check the values, you go to the next index. So currently I was checking the value of 2 with its adjacent value. Now our index, so let's say I'm iterating using an iterator I. So initially I was 0. So I was checking for 0th index. So this is basically index. Okay, fine. So the I was 0, index I. Now when I becomes 1, we are comparing 2 with we are comparing 2 with 4. Is this order correct? Can you tell me, Vijay? Yeah. So we don't need to swap here. No swapping here. Now I becomes 2. So when I is 2, we check the value 4 with its next num value in the next value in the list. So is this order correct? 4 and 3. So this order is incorrect. So what we need to do, we need to swap them. So 1, 2, 3, 4. Now when I becomes 3, 2, 3. So we have to exit the program because we don't have any neighbor right now. Fine. So this is how bubble sort works. So how many swaps did we do? We did uh, 2 swappings. So this is the total number of swapping that we are talking about right now. If the number of swappings is very large, then the bubble sort will take more time. If number of swapping is small, then it will be faster. Now, if the list is in descending order, so let's say the list was in descending order. So 4, 3, 2, 1, and you wanted to sort in ascending. So first you will swap 4 with 3, then swap 4 with 2, then swap 4 with 1. So total 3 swappings. Then 3 will be here, 2 will be here, and 1 will be here. So we will swap 3 with 2, 2 with 1, and again 3 with 1. So there will be 2 swappings. Then it will be 2 here, 1 here, and 3 here. So you will swap 2 with 1. So 1 swapping. Total 7 swapping. So this is what I'm talking about, total number of swapping. So the maximum number of swapping that will be required when the list is in descending order. Fine. So anyone, do you have any doubts? So let's go to the next question. How many passes does bubble sort make to the array in the worst case scenario for sorting n elements? So we already saw we needed to how many swaps maybe. I mean, no, it's not swap. Yeah, how many passes? So what is the correct answer? We already saw what we had to do. Anyone? We already saw what was happening. So for we if the list is in descending order, then the bubble sort will be in its worst case scenario, facing the worst case problem that it can ever find. And in that case, we have to go through each of the index in the bubble sort. The correct answer is option B. So we have to go through each of these indices. I is first 0, then 1, then 2. Fine. So it is n minus 1. It will not be n 2n. N minus 1 is the correct answer because then you have to check first for the first position, then second position, and then third position for this array of containing 4 elements. Fine. So let's go to the next question. How many pairs of adjacent elements are compared in a single pass of bubble sort algorithm? So this is a very simple question. Can you tell me? So currently we already counted the total number of swaps or comparisons that we did in each iteration in single pass. Can anyone tell me what is the answer? Right. Option B. So for each element, you have to do for each index, for each pass, you have to check n minus one other elements. So one, two, three in the first, in second two, and so on. So its correct answer is option B, which is n minus one. Fine. So let's go to the next question. The following steps are required to implement the binary search for an array sorted in ascending order. So are you familiar with binary search algorithm, everyone? So if you don't know binary search, then we can't proceed with this. Fine. So what we did in binary search. So let's say we have a list containing elements in ascending order. Fine. And we want to search for some particular value x. So what we do, we get midpoint. So first we define the start and the end limits of the list. So let's say start, and it's set to the list beginning, that is 0. And let's say we define end, which is 0, 1, 2, 3 right now. Fine. Now what we do, we compute the midpoint, which is start plus end integer division by 2. So by integer division, I mean do not take the remainder. Only take the integral part of the quotient of the result. Similarly. Now we check if x is less than midpoint. What happens if x is less than the value is less than the value at midpoint? So let's say we call this list L. So we call this list L. Then we check if x is less than the value L at midpoint. And this is L. So let's say if x is 2, So let's say x is 2. Then is what is midpoint first? Midpoint is 0 plus 3 by 2, 1.51. That is this index. Now, here we get x equals to 2. So we get the answer. Let's say x was 1. Let's say x was 1. Then what is the midpoint? Midpoint is 1, index 1, and index 1 contains 2. So now we see the value 1 is less than 2. So what we need to do? Can anyone tell me in binary search? So for sure, we know that the list is in ascending order. And now we know that the midpoint value, the value that we want to search, is less than the midpoint value. Then the value has to be present in the first of the list, first half of the list, that starting from the beginning, start value till the end value. Else it would have been the other half of the list. And then we subdivide the list again to get the answer. Fine. So let's see this problem. So these are the algorithms. So initialize the pointers low and high, initially pointing the start and the end of the array respectively. Calculate the midpoint. Compare the midpoint element. If it is equal, then the search is successful. If it's less than the target, update low to mid plus one. That is, if the value is greater than midpoint, then update low to midpoint plus one. That is, the value is present in the right half. Else, we update high to mid minus one. So the value is present in the left half of the list and repeat. Fine. Then there is a possibility that the value is not present in the list. In that case, return minus one. In that case, mid start becomes equals to the end. Low is equal, greater than equal to high. Fine. And then we return the value. So what steps would require modification if the array were in descending order? So this is true when the array is in ascending order. What we need to do if the array is in descending order? So, so let's say this was the list we had. Fine. And it was sorted in descending order. 4, 3, 1. And now I want to check for 1. And midpoint would have been this index. Then what we had to do? We had to, instead of decreasing the high to mid minus 1, we had to increase the end to start to mid plus 1. That is, this will be the start. And then this would be the end. So that means we have to reverse the direction of comparison. Reverse. So here we were checking if midpoint is less than the target update instead of less, we have to get it more. And if the midpoint is greater than target, we have to update high. So we have to, instead of greater, we have to change it to less. So which steps would require modification in case of a descending ordered list? Option. So step 2, what is step 2? Calculate midpoint. So no, we don't need to change the midpoint calculation. Step 4, repeat. No, we don't need to repeat this. Steps 3 and 4. So steps 3 says compare the midpoint and then repeat. So yeah, option C is correct. We need to change steps 3 and 4. So we essentially replace this less with greater and greater with less, and then it will work for a list sorted in descending order. Everyone, do you have any doubts? Fine. Let's move. If you have any doubts, type in the chat box. So let's proceed to the next question. Let's select the correct statements among the following. In the presence of duplicate elements in a list, binary search always finds the first occurrence of the element in the list. No, that's not true. because there is a possibility that sometime the midpoint would lie at the first occurrence or the midpoint would lie at the second occurrence. So let's go to the next option. In the presence of duplicate options, then second option says in the presence of duplicate elements in a list, binary search may or may not find the first occurrence of the element in the list. So yeah, this is true because there is a possibility that if the list is even or odd at the location of the elements, it depends. Either the midpoint can be the first element or the second element in any iteration. So that's why in the presence of duplicate elements in a list, binary search may or may not present the first occurrence. Fine. So this is correct. Let's see option C. In the presence of duplicate elements in a list, the existing binary search algorithm with minor modifications can be used to find the first occurrence of the element uh, of first occurrence of the element. But no, that's not true because it is random basically. The midpoint can lie anywhere. Fine. In the presence of duplicate elements in a list, the existing binary search can be used to find any kth number, any kth number from one to number of times the element have been repeated of the no. So this is also not correct because we can't find even the first. We can't find any kth also. Fine. So let's see the other option. In the presence of duplicate elements, the existing binary search can be used to find the first occurrence of the target element in the list. So yeah, this option was correct. Why this is correct? Because let's say we get to a particular element. So let's say we had this list. Instead of three, there was two here. Now we want to find the, so this is the list. One, one, two, three. Now we want to check if one is present in the list. So the first midpoint would be one here. Now, how to get the first occurrence if the value has been repeated? If there are duplicate elements, they will be adjacent, that's for sure. Now, let's say at midpoint we get one. Now we check the value present at the previous index of this list. If that value is also equal to this value, this means that that value is present in the first place. Then again, if the list was long, so I can again compare that value with the value present in the previous uh, index. Now, in this fashion, we can go to the first occurrence of that element in the list. Fine. So basically, the idea is if you are doing binary search, the list is essentially sorted in ascending order. Then, if you want to find the first occurrence of a particular element which has been duplicated, for any midpoint, when for any midpoint, if the midpoint lies at the first element, that's great. When you compare it with the value at the previous state, it will not be equal previous index. Otherwise, we can simply loop through all the previous values of one in this case until we reach the index where the previous value is not equal to the current value. And then we get the first occurrence of that value in the list. Fine. Option B and C both are correct. Do you have any doubts? Anyone? Anyone, do you have any doubts? Just type in the chat box. Is binary search clear to you all? So option B says if there are duplicate elements in the list, the binary search may or may not return the first occurrence of the element in the list. So let's say if we do no modification, then the midpoint can lie anywhere. It may lie at this occurrence, it may lie at this occurrence or this occurrence. Fine. But if you want to ensure that I want to find the first occurrence, then you have to check the previous values in the list. So that is the option C. Fine. Vikram, do you have any doubts in those options again? So option B says if there are duplicated elements, then it may or may not return the first occurrence. But we can make, or the option C says we can make some modification in the algorithm to get that result. Fine. So anyone else, do you have any doubt? Fine. Next question. Swapping of two numbers is an intermediate step in any algorithm that we saw. In the lecture, we use a temporary variable to swap two elements in a list. Can swapping be done without using a temporary variable? So everyone, are you familiar with the swapping algorithm? How to swap two values? So let's say we have two values A. Let's say we have two variables. A contains some value, let's say 10. Then another variable B, it contains the value 20. You want to swap these values, swap A comma B. How we can do this? So we get another temporary value, temp that stores the value of A. Now what we do, we update the value stored in variable A with the value stored in B. And now B contains the value stored in variable A. So can we do this without using any third variable? Can anyone tell me? Right now we needed a third variable temp to do this swap operation. Is there a way where we don't need this third variable? So do you have any idea how to do this swap operation without using the variable temp? So you're saying if you take temp equals to A, how A becomes B? No, we are storing the value stored in A into the variable temp. So no, swap function already uses some logic to implement this. So someone is saying if we take temp equals to A, how it becomes A equals to B. So we are not saying A equals to B right now. So first what we do, we store the value stored in the variable A into the variable temp. Then we update the value stored in the variable A with the value stored in variable B. And then finally, oh, so sorry, there was a mistake here. So here B equals to temp. This is the, now it's correct. Fine. So the correct answer is yes, we can do this without using any third variable. So let's see how we can do this. So let's say A contains 10, B contains 20. So now is what is the value of A plus B? Can anyone tell me what is the value of A plus B? 30. Now what if I say B, so let's say if I update the value stored in B with A plus B. Fine. Now what I say A equals to B minus A and then B equals to B minus A. B minus A. So let's see what happens. A plus B is 30. Now B becomes A plus B, which is 30. Now A becomes B minus A, which is 20 minus 30 minus 10, that is 20. Now B becomes B minus A. A is 20 right now, and B is 30. 30 minus 20, 10. So can you see we have swapped these values without using any third variable? So this is how we can swap these two values without using two variables without using any third variable. Depends upon the nature of elements in the list. It doesn't make any sense. It is independent upon the values in the list. So you have to swap two numbers. It doesn't matter if they are same or no. Someone is saying wrong. So please can you help me with what is wrong here? So Arindan, can you just figure out, point out what is the mistake here? Fine. So I hope none of you have any doubts in this algorithm. And this is how you swap two numbers without using any third number, third variable. Fine. So these were some basic problems that I wanted to discuss with you guys for this session. So now I have some programming problems that will be discussed after taking a break for 5 minutes. So let's meet at 7:21. So it's a break for 5 minutes. We will resume at 7:21. Yeah. Hi everyone. Do you have any doubts? Just type in the chat box. So I guess Anish has some doubts. Anyone? Do you have any doubts? So just please type in the chat box if you have any doubts. I believe no one has any doubt. So let's proceed with the final question for this session. This is the programming problem. So the problem is like this. Write a program that takes a string as input from the user and prints the frequency of each letter in the string. Fine. So let's say user input is, let's say the user inputs. So let's say the user inputs string. Ram is a boy. He's 10 years old. Fine. Now let's see if I want to compute the frequency of each alphabet in this string. Fine. So how to write this problem? So let's try to solve this. So what we can do is we can create a set, a list containing all the alphabet in this string. And let's say the string contains the elements, all the values are in lowercase. So we can say R comes one times, then A comes two times, M comes one time, I comes one time, S comes one time, B comes one time, O comes one time, and similarly Y comes one time. So this is the program that we want our program to print this output. So it asks user to enter some string from the terminal, and then the program has to count the frequency of each element in the string. So let's start doing this. So we'll solve this problem using dictionaries. So let's try to do that. Fine. So first we want the user to enter a string. So let's call it user string input. And by default, the behavior of input function is that it returns a string. So please enter your string. Fine. The user gives us a string. Now what we have to do, we have to count the frequency of strings or each alphabet uh, in the letter present in the string. So let's say our string is like this. Ram is a boy. So now let's say I want to iterate through each and every letter present in this string. RAM. So how can I do it? So what I can do, I can use for loop for I in S. So what it does, and print I. So what it does is I iterates through each element, each letter presented in the string, and then we can do any operation on that I value. So you can see it prints Ram is a boy, and this is and there are spaces also here. So this is how we access each and every element in the list. So uh, one more interesting thing I want to tell you guys is, let's say we have a dictionary D that is blank right now. Now let's see if I want to create a new entry in this dictionary. How would I do it? I need to add some key value pair, and the key is not present in the dictionary. Then how I can do it? I can use this bracket operation and pass a key value here, a new key value. Let's say new key, fine, and then add a new value to it, some value to it, fine. So what it will do, it will update the dictionary with this and a new key and the new value as its value. So this is one of the benefits of using dictionaries in Python, and I will be using this to solve this problem. So let's say we have a string, something like this, some strange string we have, fine. So let's say s equals to some strange stuff, fine. Then how to count? So let's make it more easier. So let's say s contains the string hello, right? So I want to count the total number of times each letter is occurring in this string. So what I can say, I can create a frequency dictionary that is blank right now. Now what I do, I iterate through each of the values in this string and add them as a key to this dictionary. And for value, what I can do, I can assign the value 0 to that string, to that dictionary. Fine. So uh, for I in S, what we have to do, we have to add a new key that is I, and the value that I'm assigning is 0 right now. So now when you check the frequency dictionary, you can see it will contain all the elements in this string as keys for this dictionary. All the letters in this string as keys in this dictionary, and each key has a value of 0. Now the next thing what we have to do is we have to count the number of occurrences. So what I can do, I can again iterate through each character in the string. Now what I have to do, I have to update the occurrence. So that means if in the frequency dictionary, what I have to do, I have to go to that key that corresponds to a particular letter. So let's say the first letter is H. The frequency at H has to be updated by 1. So earlier it was 0, saying that the H has occurred 0 times. Now when I do this, it says H has occurred 1 times. And if H again occurs, then it will do update it again. So now when you see the value of this frequency dictionary, you can see it says H occurs 1 time, E occurs 1 times, L occurs 2 times, and O occurs 1 times. Fine. So this is how you write a program using dictionaries in Python. This is how you can. So this is how you can create a program that counts the total frequency of each and element in the string. So anyone, do you have any doubts? So yeah, someone is saying they want me to discuss the topic on speech recognition. So I don't have any. So I can't go through the session that session again, because you can go back to the lecture notes, lecture videos, and see what is being taught there. Again, I don't have any problems related to the topic, so I don't won't be covering that here. Fine. So anyone, do you have any doubt in this problem? So do you understand the logic behind this program? So now you are able to use dictionaries for various operations. Anyone? So what is done in line 48? So what I'm saying is for each letter in this string s, so it is being iterated through this iterator I. What you have to do, you have to go to the dictionary frequency, go to the key value I, and I is currently h, update that value by one. So add one to that value. Fine. So let's say if there was I was h, then the frequency value at h is zero, so it becomes one. Now when I becomes e, the value is zero again, it becomes one. When I is l, then the value was zero, it becomes one. Then again I becomes l, then the value at l was one. Now updating it again makes it two. Then we get I becomes O and O contains zero. So it gets one updated by one, that is one. So in this way, you see, we were able to count the number of times each of these keys were occurring in the dictionary frequency. So basically, we are simply counting the number of times these keys are being are occurring in the occurring in the string S. Fine. So anyone, do you have any doubts for this session? So if you have any doubts, please type in the chat box. So anyone, do you have any doubts? Then please type in the chat box. So yeah, so if you have any doubts for this session, please type in the chat box. So if you have any doubts, please type in the chat box. I'm still here. And yeah. If you have no doubts, you can leave the session. Yeah, you can. So if you want, I can discuss problems from the previous sessions also. If you have any doubt in any topic that I have covered till today, you can ask me. So if you have any doubts, so I hope every one of you were able to solve these problems. Basic, write a program to compute matrix sum. Were you able to solve these problems? These are programming problems I gave you in the previous sessions. If you want answers to any of these problems also, you can ask me. So let me share my screen again. So if you want answer to these problems, you can ask me. Okay, so someone is asking me to write a program for computing matrix vector product. No, right. So everyone, are you familiar with matrix vector product? Are you familiar with matrix vector product, everyone? So I hope you have studied in this your basic high school classes. Matrix vector product. So let's say we have a matrix mat. Fine. So let's forget about programming right now, and first let's think of what is a matrix. So what is a matrix? So let's say I have a matrix like this. So everyone, are you familiar that this is a matrix? I hope you have studied this in your. So are you familiar with matrices, Anshu? Uh, And what is a vector? So let's say we have this matrix M and we have this vector V. Fine. Then what is the value of M into V? So we have a matrix 1, 2, 3, 4 that are the entries, and there is a vector 5, comma 6. So Anshu, can you see this? So what would be the output? So the matrix is 2 cross 2, 2 cross 2, and the vector is of dimensions 2 cross 1. So what will be the output of MV? MV will be 2 cross 1. So do you understand this basic notion in matrix algebra, Anshu? Fine. So what will the values? So it will be a vector. We all know that this result will be a vector 2 cross 1. And how to compute that value? The value at the first, you take the first column, first row of the matrix, and multiply with the first column in the second matrix. I mean, if it's a vector, just multiply it with the second, first, multiply it with the vector values. So 1 into 5 plus 2 into 6. Similarly, the second entry would be 5 plus 12, which is 17. Similarly, the second will be 3 into 5 plus 4 into 6. So what is this? 5 to 15 or 6 to 24, 39. Fine. So the output would be a vector containing, MV would be a vector containing the entries 17, comma 39. So this is a basic algorithm for computing matrix vector product. Another way in linear algebra classes, you can find another interpretation, that is 5 into the first column vector of the matrix M plus 6 into the second column vector of the matrix M. So what does that mean? 5, that's 5 into first column is 1, comma 3 plus 6 into 2, comma 4. So what is this value? This value is 5 plus 12, and the second value is 15 plus 24, which is exactly equal to our algorithm. Fine. So now the first thing, how to represent matrices in Python. So we can use list of lists. So how I can represent this matrix 1, 2, 3, 4. So let's take out our console. So we want to represent our matrix. So we can create a list of lists. Each list in the list represents a arrow, represents a row of the matrix. So what is the row of first row in this matrix? 1 comma 2. So first list will contain the entries 1 comma 2. Then the second row is 3 comma 4. The entries would be 3 comma 4. So let's say this is our matrix M. Fine. This is our matrix M. Now what I can do, I can define my vector V. Now I have to define my vector V. And since for vectors, what we do, we represent all the values in a single list. So the vector is 5 comma 6. Fine. So now we want to write a program that computes this matrix vector product. Fine. So let's create the output vector MV and uh, stay. Let's enter blank here, or maybe MV is equals to 0 comma 0. Then let's think what to do. We want to update the value at the location 0 for the vector MV, that is the product. That value would be M at the first row multiply the by the vector V. So M at 1 dot product basically. I'm at 1 and V at 0. So I'm at 1 comma, I'm at 0 comma 1, 0 comma 0 into V at 0 plus I'm at 0 comma 1 into V at 1. So here you can see the first value becomes 17. Similarly, the value at index 1 of the output vector is M at the second row multiplied by the vector V. So basically row second and the value entry 0 with the 0th entry of the vector 0 vector V plus I'm at second row the second entry multiplied by the second entry of the vector V. And now you will see you get the answer MV equals to 17 into 17 comma 39. Fine. So do you get this algorithm, Anshu? So let's write this logic. So what we are doing for row in. So let's say I defined the total number of rows in the matrix as rows, and we have two rows here, and define the total number of columns as columns, which is two here. So for row in range rows, so for each row, what we have to do. So one thing that is, hmm, so the value at row for the output vector is 0. Let's initialize the value 0. Now for call in range calls, what we have to do? We have to do matrix. So MV at particular row. What is this value? MV at 0 was M at row. Row is fixed and the column is varying. That is by the value call into vector V at call. Fine. MV at row plus equals to. So we are simply adding those values. So now when you run this code, you will see you will get the answer 17 comma 39. So this is the program that will help you to compute matrix vector product. Ansh, do you understand this, Anshu? Fine, great. So now I hope you will be able to solve the matrix product problem also. So I guess few more minutes are left in this session. If you have any small doubts, you can ask me or we can end this session. So element-wise matrix product, it's not that difficult. So what is element-wise matrix product? So let's see. So let's see we have a matrix like this. Let's say matrix M1. It goes like this, 3, 4. And then we have the matrix M2, 5, 6, 7, 8. Then what is element-wise product among those? Element-wise product output, it would be 1 into 5, 2 into 6, then 3 into 7, then 4 into 8. So this is the element-wise product for these matrices. So let's see, let's say we declare our first matrix 1, comma 2, 3, comma 4. Sorry, fine. Let's declare our second matrix 5, comma 6, comma 6, comma 7. Fine. So we have M1 and M2. Sorry. Yeah. So now what we want to compute? We want to compute element-wise product. So let's call it element-wise product is an output matrix. And let's initialize the values 0, comma 0, 0 values to this matrix. Now what we have to do? We have to iterate through all the rows of the matrix, then for chain range calls, and the value element-wise prod at I, comma j is basically simply the product of values in the matrix I and j. M1 and M2. M1 at I, comma j into M2 at I, comma j. That's it. That's the answer. When you check the value, you will get the answer. Fine. Krishna, is this clear? Fine. Great. So that's it for today's session. If you guys have any doubts, please type in. I will take in the next sessions. So yeah, that's it. Thank you.